Good day, everyone. My name is Mpochivase. I'm a UNISA student, currently doing my advanced diploma in civil engineering. So today I'll be presenting to you about the road design procedure. Before any constructions of the road should be designed, because the road is built as any structure. So a designer, before any other thing, a designer must conduct a feasibility study, which comprises of site inspection, road analysis, and traffic analysis, before any decision is taken regarding the alignment and profiling. The designer will inspect the topographical survey, geotechnical surveys, and environmental surveys. These surveys are conducted to help pave way for a decision and on the proper alignment, type of material to use while building that road. Okay, let me start with the topographical survey. A designer should not design a road before knowing the terrain of the area in which he's working on, because that is going to help the designer in the road alignment, which is vertical alignment and horizontal alignment. When we come to the geotechnical survey, even a designer is not allowed to design a road without knowing the material around the area in which the road is going to be built. In most cases, you'll outsource the geologists in the project. They'll go and take samples on site. The engineer is the one who's going to spot points or help with the geologist in taking the samples. The environmental survey, the designer must know, for instance, which tree to not cut during the cut and spoil of the road, the excavation, opening up the road. So this aspect of environmental survey is going to help the designer also in aligning the road. If the designer, for instance, do not go to site and then just design from the office, you will find out that the road is going straight to a river, and you can't block the river. Environmentally wise, it's not allowed, or maybe it's going towards some trees which are very important, like the morula tree. So the designer in all cases must go to site to survey these aspects or these elements. As soon as the survey is done, the resultant data is loaded in Civil Design or any other program such as 3D maps, civil 3D maps. Okay, to start with the generation of the long section. In this case, a decision is made on the type of alignment necessary for the type of the terrain under design. So this survey information is going to help the designer in aligning the road. So survey, you can see that it goes in with topography, because it is all about terrain. The surveyor must respond to the terrain of that environment. So it is one of the very most important aspects to consider. At this meeting, a decision is taken on the type of feature suitable for the alignment. This is what exactly I was talking about. So here I'm going to take you through how to operate civil design with those survey information. You switch to survey mode, create a new project, you're going to import coordinates, remove duplicate points, join the break lines to all feature points after switching to terrain mode, fill all break lines to all feature points, triangulate by filling in the remaining break lines to support shots, check the break line integrity of the model by validation, select the root file and name the layers, type the horizontal alignment with a mouse, coordinate horizontal alignment, extract ground cross sections from the terrain DTM and save to appropriate road layer. Step through the check cross section by means of graphical edit, enter the vertical alignment by means of editing. Generate the vertical alignment level by generating the level and also show the low points for drainage purpose. Obviously, a drainage can be on the highest point, it should be on the lowest point. So this survey will help you come out with your lowest point, of which your drainage structure for sure it must be on the lowest point, such as culverts or stormwater pipes. Create the road template by means of template editor. Add the road template of the road design using the template path mode. Enter the super elevation data around the horizontal curve using the edge level mode. Generate edge levels. Apply the template to the road. Step through and check the road cross sections. Calculate volumes and mass hole volumes. Plot the plan, long section, cross section, and mass hole diagram drawings. So in this case, for the geometric design, we refer ourselves to TRH17. It's the standard for road design and for geometrical and pavement design. So here in geometric design, geometric design consists of the alignments. It can be road alignment. It can be vertical alignment, horizontal alignment. But these work hand in hand. You can easily see this in the cross section or long sections. So hence they've been talking about the cross sections and long sections. Okay, geotechnical report analysis. Decision on the modification of the existing and import road construction material. Fine. In this case, it is very, very important that a designer gets the geotechnical report analysis. Why? It is because it helps the designer in knowing the material is going to design using. For instance, some areas don't have a good material. You'll find that the whole areas consist of sand, maybe in a desert area, or rather clay. So it is important that the geologist should submit the report based on the material, because the material will help you even in the budget. You should know whether you are going to import the material or you'll get the material from site or from your borrow pit, which is nearer the site. So it is very, very important, even looking at the budget and the period of the contract, obviously. Analyze traffic study and the impact on the road to be designed. Okay, it is very, very important also for a designer to know the traffic information on the particular road, or let me say that area. For instance, the traffic in my N1 road, National Road 1, can be compared to the traffic stream in my village. Why? Is because this information is going to help the designer either in the material to use, but also in the number of layers the road should be consist of, because I'm sure the number of layers on my N1 compared to the number of layers in my street, they are not the same. Why? It's because of the traffic study. There's more traffic on my N1 and there's less traffic here around my street. Choosing the best pavement from geotechnical survey and the traffic study using TRH4 for the structural design and flexible pavement for urban and rural roads. It is what I was explaining just now. A decision is therefore taken on the best possible surfacing type using all the information collected during analysis period. The design is done using TRH3 for the design and construction of surfaces. Top management is okay. So while using that when you talk about the type of seals, for instance, you can't go and pave the whole N1 because pave needs a lot of maintenance, and that road, the N1 road, is very busy. So hence you'll have to use rather wash asphalt or other means of surfacing. So a designer, they still also help the designer in considering even the alignment. For instance, if the area is a mountainous area and there are a lot of curves, it would be risky for a designer to put horse asphalt. Why? It's because the area is too sleepy. I mean, water asphalt will be too sleepy when there's rain. So it would be very, very dangerous for that road during rainy periods. So drainage structure are designed using human settlement planning and design compiled by CSIR. This includes any decision and action related to the improvement of the effectiveness of the quality management system and its process, improvement and product related to customer requirements and resource needs. Installation of relevant traffic information and regulation signages. This is discussed with the top, okay, and the ensure outgoing compliance with the established quality. Okay. For sure, road marks are implemented by the designer, because once you design something, you must make sure that that thing you are designing, it is user friendly, either in building or in every other thing you are building. But in this case, the safety of the road is controlled by the signages and the road markings. In my street, obviously, there should be humps, or the designer should consider humps, stop signs, and many other things. Unlike on the N1, whereby there are no citizens nearby, so that is a free flow traffic. You can't expect a stop sign on my N1. You can't expect robots. You understand? So that's why they are different in terms of signages and road marking. So the designer is very, very responsible of those elements. The road should be user friendly concerning these things. If there's a school nearby, you know you should put a hump before and a hump after the gate of the school. So those are some of the traffic control aspects of which the designer must have in mind while designing. Okay, I think I'm done with the presentation, but all in all, what I was trying to put up here is that when designing a road, there are a lot of aspects to consider before going to site and do the construction of the works. So even in the design report, you must put these aspects. You must tell what type of climate you are expecting in the area, the topography, the terrain, the material you want to use, the road reserve, the pavement layers. So those are the when designing. Those are things you should consider. When you said you have designed, you must be telling us about those elements. So yeah, so those are things a designer should take very seriously before submitting the report. Everything should be clear: the road reserve, the road width, the curve should be calculated as well, all vertical and horizontal curves. So yeah, I think all in all, I've said it all, and I thank you for the opportunity to